Welcome back, ladies and gentlemen. Today we will go over this thing called limiting reagent. Okay, so far we have done what? So far we have done mole to mole. We did that conversion there. Mass to mole, we did that, and mass to mass, we've done that. Okay, just a quick review on these. To do these, you have to know the order of grams, mole, grams. So if you haven't done all these three, make sure you go back and finish those before you can start on this limiting reagent ones. Because if you don't know these, you won't be able to do that one, the new one. So if you've been absent or you're just a little behind, go back, watch my other videos, and complete those before you continue on this one. Limiting reagent is, we mentioned the definition already. Limiting reactant, limiting reagent, the same thing. Okay, reactant as well, reactant. Okay, a couple definitions. We mentioned a couple definitions already, right? The first one is the ingredient that runs out first, the reactant that runs out first, the substance that runs out first. So just go runs out first. Okay, that's one. Another definition is it stops a reaction from continue, stops a reaction. And if you have two or more ingredients, then of course you do. That's how you know which one runs out first, which one is excess. Okay, so the reactant, or I can't say reactant. So the ingredient that produces the least product. Okay, so three common definitions there: the ingredient that runs out first, the ingredient that stops a reaction because we can't use up any of the other stuff because we run out of it, and then the ingredient that produces the least product. Okay, those three definitions. So how do you find it? If you refer back to the s'mores lab we did earlier, a couple classes ago, the s'mores lab, if we had, let's say, 8 graham crackers, and we have let's see, pick a number, 12 chocolate. Okay, no, 12 is not a good number. Let's say we have 10 chocolate. 10. Let's do 10. Some classes I said use 3 chocolates. Some classes I said use 4. In this case, we'll use 4 chocolates per s'mores. Okay. 8 graham crackers. How many graham crackers per s'more? 1 s'more is 2 graham crackers. So 8 divided by 2 is 4 s'mores. 10 chocolate. 4 chocolate per s'more. That'll give us 2.5 s'mores. So how many can we make? We can make the one that's less, right? The one that's less product here. And what is the limiting reagent or reactant? The limiting reactant is the material that runs out first, which is chocolate. So chocolate is the limiting reagent or reactant. And we can only make, this is the maximum that can be produced. Okay? That means we'll have extra of something. What are we going to have extras of? We're going to have extra graham crackers, right? Because we didn't use all 8 graham crackers, so we'll have extra graham crackers. And so for today's lesson, you'll figure out the limiting reactant using chemical equations, and you'll figure out excess as well. So we just skipped over the percent yield. The percent yield, it's 2 pages there in the packet. We're skipping over that. So we'll come back to that later. At this point, you should have 1 through 35 done already. We'll skip to 36 to 40 for now, and then we'll do this page. Limiting reactant worksheet 1. So please turn to that page, and I would like to do, I'll go ahead and do number 3 with you because I don't want to always do the easy one, right? That's not cool. So let's do that. Number 3, consider the following reaction. There you go. Consider the following reaction. Let me focus this. Yes, very good. So consider the following reaction. So if that little space there is not enough for you to work your problem, get a new sheet of paper. Get a separate sheet of paper, do it on a separate sheet of paper, staple it to this, and you'll be just fine. Okay, consider the following reaction. 2Cu2 plus 4Ki plus 2Cui, yields 2Cui plus 4KCl plus 2I2. It says A, when 1.56, so I have given is 0.56 mole of CuCl2 and 0.64 mole of Ki. That's my two given. How many moles of I2 are formed? So we're trying to get to I2, both of them, to mole of I2. But this is nice. This is a mole-to-mole question, so it's real easy. Okay, so we have to set up the problem twice. One for each reactant to see which one produces less. Okay, so 0.56 mole of CuCl2, and copy the unit down here, mole of CuCl2, and we're trying to get to mole of I2. If you remember the order, it's grams, mole, grams. We're only dealing with these two in the middle right now. There's no grams involved in this, so that goes out. So it's just mole to mole. Mole of one thing to mole of the next thing. Okay? So mole over mole, where do I get the number? I get it from the balance equation. I2 is 1. CuCl2 is 2. Then I'll get an answer. Okay? And then the other one, I set up the other one just exactly the same as that. There you go. Where's the other one? 0.64 mole of Ki. Again, this is a mole to mole. So the mole up here and then the mole of Ki goes down here because, again, follow the pattern, guys. Follow the pattern. Get the units downstairs like that. Downstairs diagonally to there. We're going to mole of I as well. We have to go to mole of the same thing. I is 1 still. In front of Ki is a 4. 4. Okay. So I calculate these. Right? 0.56. Handy dandy calculator there. 0.56 divided by 2 times 1 divided by 2, 0.28. So the top one's 0.28. And the bottom one, 0.64 divided by 4, 0.64 divided by 4. Oops. 0.64 divided by 4. 0.16. 0.16 mole of I, mole of I2, mole of I2. So there you have it. First question is, how many moles of I2 are formed? So the answer is the one that's less. Okay, so it's 0.16. So it's 0.16 mole of I2 there. What is the limiting reactant? So what material produces less? What was the starting material that produces this? And it's Ki. Ki is the limiting reactant. Ki is the limiting reactant. So it's Ki. And so the question is, what for the reactant in excess, how many moles are left over at the end of the reaction? Okay, so which one's excess? Let's identify the excess versus the extra. We run out of Ki. That's limiting reactant. So the excess is the CuCl2 excess. We're going to have some extra. Okay, so in order to know how much extra is, this is what we have. We have 0.56 mole of CuCl2. We need to know how much we used, and then so that we know the amount that's excess. Okay? So how do we know how much we used? We know we made how much? We produced 0.16 mole of I2. Okay? We produced that much. So then we can use this information to find how much CuCl2 we used. So 0.16 mole of I2. Let's see how much copper chloride I used to make that. So mole of I2 goes down here. Mole of CuCl2 goes up there. Mole of I2 goes here. CuCl2 goes here. Okay. So then we cross this out and they cancel each other out. 0.16 times 2 is 0.32 moles of CuCl2. We use this much. This is used to make that same amount of I2. Alright? So we use that much, so we have to subtract that from what we started. And the excess, we'll get our excess when we subtract the amount we have, how much we use. So it's 0.24 mole of CuCl2. That's the excess. Okay? That's that, guys. So this is actually pretty easy. This is all mole to mole. So that's not bad. That's not bad. So do number 1, 3, and 4. 1, 3, and 4. I'm going to have to find another worksheet that is that involves the grams in here. So go ahead and do the 1, 3, and 4, and I'll come back with pause it, do that, and I'll come back with a more complicated one. BRB. Pause it.